start with today's daily Leetcode problem, right? So this is 1061 lexicographically smallest equivalent string. The date is 14/123, right? And we have been given two strings, S1 and S2, okay? And there is a third string also, which is base string. Now we say that S1 and S2 are having equivalent characters. Sorry, yeah. S1 of I, the index like S1 of I and S2 of I are equivalent character. What does it mean? For example, S1 is ABC, S2 is CDE. Obviously, they are of same length. So A is equivalent to C because first character both are the first index. So A is equal to C, not equal to but equivalent to, right? B and D are equivalent, C and E are equivalent, so you'll say we have this where double equals to represent equivalent sign, right? So A is equivalent to C, B is equivalent to C, D, C is equivalent to E. So C is also equivalent to A, C is also equivalent to E. It means A and E are also equivalent. That is the thing. So basically how I'm saying this, because the equivalent character follow this three relation: equivalence relation, three equivalence relations, reflexive, obviously A is obviously equivalent to A. Symmetric, if A equal to B, then B is also equivalent to A. Transitive, so transitive, what I have just shown, if A and C are equivalent, C and E are equivalent, so E and A are also equivalent. Now you need to convert this S1, not S1, you need to convert this base string into some another string which is equivalent to base string. Okay, you are given equivalent to this C D this. So what do you mean A C D and A B are equivalent of a hmm. So this is S1, this is S2. You have some equivalent pairs like A is equivalent to C, B is equivalent to D, C is equivalent to E. Now you have a given base string is equal to EED. Now you have to tell me what are the all strings that are equivalent to E. So instead of E, what you can place? I just told you that A and C and E, these three are equivalent in each other. B and D are equivalent in each other. So instead of E, you can place either A, you can place either C, or E is obviously there. So yeah, instead of each E, so now you want lexicographically smallest. So you should place A instead of E, right? And for this E also you'll place A, and for this D you can place D or B. So you will place B because it's lexicographically smallest. So AAB is a lexicographically smallest string. Also ACD is also a good equivalent because E is also equivalent to C. But we are looking for the lexicographically smallest substring of BSTR. Okay, now let's move out to example. Return the lexicographically smallest string of the BSTR using any equivalence relation from the S1 and S2. So Morris, Parker, and this. Okay, this is, I think I have already done for you. So Parker and Morris are the two strings, and P is equivalent to M. That's why it is shown over here. A is equivalent to O. R is equivalent to R, obviously, as well as R is equivalent to K. And R is obviously equivalent to S also. So these are the three things. R is equivalent to K and equivalent to S also. So K is also equivalent to S, and E is also equivalent to I. So this is the equivalence relation that you have. You can apply transitive or something like that to thing. Obviously, everyone is a representative element of themselves. So inside this component, okay. So why I have marked this in square brackets, because this is the smallest. Okay. Now I want parser, the is the my base string. I want the equivalent string, lexicographically smallest equivalent string for parser. So instead of P, what can I place? I can place either P or M. M is smaller, so I'll place M. That's why I have made it as a representative element, and I have put this into square brackets. A is also smaller, so square brackets means representative element. A you will not replace. R you can replace with K or S. You will replace with K because K is smaller, and you will make K as a representative element for both R and S. E is obviously fine because I is greater, so E is representative element and R representative element was K. So MACH is the basically the answer for this one. Now how I'm saying this, do you getting any idea why I'm saying this representative element? This is obviously what we do in DSU, na, disjoint set union. So it means P and M are in a one set where the set is can be set have representative element as M. So there is something like you can say there is an edge from P to M and M to P. These both are equivalent, something like that. So this is a connected component, and where M is a representative element. A and O is a connected component. A is a representative element. So I'm connecting this problem now with a graph and something like DSU. Obviously, you know that DSU is always not related to graph. Somewhere the graph exists, but DSU doesn't exist. Obviously, that is. Questions are like that, DFS BFS questions. But there are also problems where DSU is implemented but graph is not needed as such, but you can also keep this as a graph. You can say that there is an edge between P or M, or you cannot just say, you can just say that okay, this is just belonging to a same set. Okay, so that's also the thing. I have not created a graph, I have just implemented a DSU. If you think this is my find parent function, and DSU function I have not separately written, I have just written in the logic of this itself. So now let's start with the DSU, right? Do you get the idea why it's a DSU? So P and M belongs to a same component. R, K, and S belongs to a same component. So you can either draw edge from R to K, K to S, S to R, or no. So every edge. So for example, A, B, C, D are in same component. What does it mean? There is a edge from A to every other. So B to C to D, there is an edge. From B also there is an edge to A to C and D. So these are all connected, strongly connected components. And there is a one representative element which is the smallest of all that you will place in place of every other element in the of that component because you want a lexicographically smallest. Okay, so that's all about the approach. Let's do this. So I will run a for loop. Basically, let's create a vector because of parent, vector of parent, which is normally present in the DSU kind of thing. So I'm making it 26 comma minus 1. We'll use it, and basically, first of all, when I equal to 0 and I less than n, I plus plus, I have to call on DSU for s1 of I, because I'm merging which two elements I am keeping in the same component, s2 of I. These are equivalent elements, so this will be in a same uh, component, and then we will see which one is smaller. Based on that, we'll make representative elements, and after final answer would be coming out from int I is less than bs dot size base string and I plus plus, and uh, string I'm creating, let's say x, I'm creating string as x, and x plus equal to find the parent, ultimate parent for this bs of I. What is ultimate parent of bs of I? Minus a for that, because okay, also you should know that we are dealing with 26 element, which means we are dealing with the integers representing the characters. I'm not representing character a as a, I'm representing it as 0, and a to z are represented as 0 to 25, something like that, and we'll return our final string. That's the whole logic of the problem if you know how to do DSU. Okay? Because now only thing which is left is DFU and find parent function. This which is also a, part of a DSU kind of thing. So this is all what you need to do. You have to take out the two elements which you know that they will be in the same component. So make out component for them and keep them in the one same disjoint set, such that a representative element will be something like the final parent, and then you will just ask for representative element for each of the character present in BS. So P representative element is M, for A is A, for R is K, and so on. So now let's implement DSU is not returning us anything, so you can just keep it void DSU. It is taking us two characters, or you can just pass two integers also. But now I have written character, so let's take character C1 and C2 character, convert them integer I1 and I2, which is equal to C1 minus A simply, and I2 is equal to C2 minus A again, and then what you need to do, you need to call on the DSU kind of thing. How you will call it DSU? You'll just say key, okay, int P1 is equal to ultimate parent. So how I'm finding ultimate, we're using find parent function of I1, and P2 is equal to ultimate parent find parent of I2, and then we'll see if P1 is lesser than P2, which means P1 has a chance to be a representative element, because not P1 but character 1 is representative element for character 2, because yeah, its parent P1 is lesser than P2. So lesser than means in terms of 0 1 I'm talking about. So lesser than means A has indexing 0 and C has indexing 2. So lesser means A is lexicographically small. Okay, so whatever find I'm having as a parent, this is a lecture graphically smaller. So this basically now I'm combining this P1 comma P2, not P1 comma P2, I'm combining I1 with I2. Now I saw that I1 is basically having something like representative element as P1, and I2 is belonging to maybe different set or same set. Okay, if they are already belonging to same set, you don't need to do anything. If P1 is equal to P2, then you continue this, because their representative element is currently same, continue. So initially they are representative element is -1. That's why I have created -1. You can also say they are initially representative element for a particular character is that character itself. You can initialize that also, like A to 0, B to 1. But I've just initialized it by -1. That's both ways. It's fine. But now you are dealing with the two elements. They have some what representative elements, and this belongs to some other set and this belongs to some other set. Now you are combining these two sets. You'll combine based on which representative element is smallest of all. So that should be the parent of all. That should be parent, and that should be the ultimate parent, and that should be the ultimate representative. So for that, if you say p1 is the ultimate representative, which is smallest of all, so you will say key parent of p2 is equal to p1. That's how we do it. Okay, now else what you can do, parent of p1 is equal to p2, because p2 is smaller, or even if it is equal to, you will do that. Okay, for equal to, you're not doing anything, so that's fine. Now what I'm saying, that you can write this logic in just one line, which is parent of let's see what we are doing, and let's I do it over here. Parent of maximum among p1 comma p2, which is maximum is equal to minimum of comma p1 comma p2, which is minimum, that is going to be ultimate parent, and this is going to be children, which is maximum. So this representative element is this. Okay, that's how you can say it. Now just find parent function is left, I think. All we need to do, should work fine, and let's find parent. That's also really simple. What I'm passing an integer in this. I'm not passing a character, so no need to convert into something like character. Passing an integer, let's say x. You will say just return if x is equal to -1. No, if parent of x is equal to -1, which means it is just that it's yeah, you can say it's parent of itself, or it is just present in a set where there is only just this element. Okay, so you'll say key return what, return x only. Otherwise, so basically in this case, parent of x is x itself. Parent of x is equal to parent of x. That's what you need to do. Now let's try to run this up. I think n we are missing, n is equal to, or maybe you can write it as s1 dot size. Parent is undeclared. Okay, so parent, I'm defining it over here. I can pass it over here, or you can just declare it over there. I don't know. I don't think so. You can declare it over there. One thing which you can do is the global initialization vector par parent and pad dot resize 26 or -1. This would work. Continue. Spelling गलत है क्या? Not in the loop statement. So you can say return. There are already code, otherwise you do this. BS is not defined, so BS ko BS. Let's make it BS base string. Let's see if find parent good. I know DSU is good, but find parent. Okay, parser ki jagah there is Morris. Okay, I think there is an issue with the character to integer conversion part. DSU of S1 of I, comma S2 of I integer. Find parent P1 is equal to P2, then return if both the parents are equal. parent of x is equal to -1, then return x. Otherwise, parent of x is equal to return parent of x, which is equal to parent of x. Find parent, I think I need to write over here for parent of x. Even p2 then return. Now it's looking good. Let's try to submit this up. Yeah, that was obviously a big issue that I just wrote parent of parent, whereas I need to write find parent of parent x, because you just don't you have to go till very end until that is not happening. You want a representative element, that if it's not a representative element you call on its parent. If parent is not representative element, then you call on their parent, grandparent, and so on, so on, so on. Otherwise, one point you will get a representative element, you will return that. Okay, so that is all about it. Yeah, that's all about it. How you have to do DSU and how you have to return the answer. First do DSU, and then find parent will store all the representative elements, like will help you to get all the representative elements. And finally your parent array is very good, that every character which is present in the base string will have, which have a parent element which is having a representative element, will have that into this parent, and then you'll just call and find parent for that element and just return answer for that. Okay guys, bye. So you should know something about DSU. That's all about this problem, like nothing else but a basic DSU problem. As you can see, that's why I separated this DSU and find parent part, because that is the pretty standard part, which you just know by using the DSU. Otherwise, it's not nothing else but just by calculating. Just you should know that which two elements I am creating a disjoint set for. So these are the two elements, and then after forming the disjoint set, how my representative elements are looking like. This is find parent is to find out the representative element for BS of I and returning that. Okay guys, bye.